Welcome to our second video of solving integrals. Today this exercise will be find derivative of fx. This is what we will put the derivative. It's equal to the integral going from 0 to module of sine x ln t dt. To solve this exercise, you need to remember the Leibniz rule. I will put it there. And it tells to us something interesting. The derivative of ax going to bx in the function fx is the f of bx, and then the bx is our inner function times the b derivative x, and minus f in the ax, and this is our inner function, this is our outer function, times the a derivative x. If you look for this formula again, you will see that the Leibniz rule will apply only when you have a variable in the upper or lower bounds of the integral. Then this is the exact case that we have here. We have a variable inside the upper bound of this integral. Then automatically we will solve this problem using the Leibniz rule. Let's move on. Oops. Okay, it's right now. Using the formula, we can say that this whole thing is equal to f of the bx. Here my bx will be the module of sine x, right? And I forgot to say, our fx function will be the ln t, and then this will be the f of module of sine x, right, times the derivative of module of sine x. I will put it here, module of sine x derivative, right, minus the f(ax) times a derivative x. If you look right, the derivative of 0 will be 0 also. Then all this whole thing will be vanished. Then we don't need to consider it for our count, right? And this is equal to the f of sine x will be ln of module of sine x times the derivative of the sine x, the module of sine x. I will do this in a separated slide because it's not intuitive. I will need to explain this more. Let's do the derivative of sine x, what it would be, right? We can write this, the module, as a function that have a square root of a squared also. This is the same meaning of the module, and we can work with this definition to try to understand what it would be the derivative. And only to turn this more consistent, I can change the colors of the functions only to let it more easy, right? And in the blue, this is my other function, because we are going to use the chain rule for solve this. And in the red, this is our inner function. Let's apply the chain rule to solve this derivative. The square root of a squared, all this thing derivative will be equal to, we can rewrite this square root as a power, right? Let's do it. And this will be the a squared and elevated to 1 over 2. All the thing takes into derivative, right? Let's move on. And okay, it's more clear now of what we are going to do. Using the chain rule, we will need to use the famous rule, right? To take this power behind the a squared, let's put it, then it will be 1 over 2 times, right? 1 over 2 minus 1 will be this thing, a squared, minus 1 over 2 times the derivative of the inner function, that will be 2a, right? This is 2a. And okay, and it will be 1 over 2 times, look at this power, this is a negative power. What we do is put this in the denominator of our fraction, right? Let's put it now, and this will be okay, a squared in the power of 1 over 2, right, times 2a. Okay, we can rewrite this. Let's rewrite it again, and it will be 2a over 2, right? A squared elevated to 1 over 2 will be the square root of a squared. We said before that the square root of a squared is the modulo of a. Let's put it here again, and it will be 2a. This a is looking like a 0, but it's a. Okay, over 2 the modulo of a. Look at this 2, we can vanish it, okay, and it will be the a over the modulo of a. And this is the answer of what is the modulo of the a squared. It takes into the derivative, right? This is the derivative of this thing here. This is it's far away. Yes, this is the answer for this question, the derivative of square root of a squared, right? Let's move back. We have the modulo of sine x takes into the derivative. We know that would be the sine x, right? Sine x over the modulo of sine x and it's look like what we did it before, right? And remember that we are using the chain rule. This is the derivative of this, all this function, the outer function evaluated inside the inner function, plus, it's not the end yet, plus the derivative of the inner function, the derivative of the inner function of sine x is the cosine x, and this is our final answer for this question. The derivative of fx here is the ln of the modulo of sine x times the sine x over the modulo of sine x times the cosine x. This is our final answer. Hope it helped you.